So my name is Jainam Patel and I am a CFD application engineer at Paanduv application. And today I will show you the GUI of the AM PravaH software. So right now I am launching the AM PravaH. So this is how AM PravaH GUI actually looks like, home screen. I think you can see the GUI of the AM PravaH. Okay. So in AM PravaH GUI, there are main 5 different modules: macro scale LPBF, macro scale WLAM, microstructure, Q, and AI. So in the it's a simple and user-friendly GUI. So this one is the home button. By clicking the home button, we can come back to the home page, and we can see that there's a written project name. User can change the project name to any project name that for its project, and below that there's a create new button. So after clicking the create new button, there is a option new window tab actually open there. It's a choose directory. So user has to select the directory where he or she want to save the project. Okay. Below that there's a load project option is there. After selecting the load project, again there is a directory will open, and user can select the .prava file wherever the project actually saved. So after selecting it, user can load the project also. Now let's begin with the macroscale LPBF module. So this one is the macroscale LPBF module. Here on the left side, there is a settings options are there, and below that there is a execution options are there. Okay, and we can see that on the settings there are 3 options: material, process, and simulation. And in the execution, there is a add to queue mode, save all, run solver, resume, launch console, show powder spreading, and show results, and save and terminate. And below that there is a help button is there. So I will explain one by one what is the material here. So after selecting on the material, there is a new window actually open there on the material. So user can select the by default given material by the AM PravaH tie 6 Inconel 718. These are the materials we are actually providing. And also there is a shielding gas option is there. So there are few shielding gas material properties are there. So after selecting the each material property on the right side, GUI actually changing. Okay, there's a third option is vaporization. So user can select the vaporization on and off. So there are total 4 phases are there as a mention. Okay. And on the below side, there's a save button is there. So user can change the solid, molten, vapor, and gas properties of that material. So I will explain one by one. On the solid, after selecting the solid button, there is some few properties actually shown on the solid tabs. One is solid alloy properties, where molecular weights, density, specific heat, and thermal conductivity. These are property actually temperature dependent properties. So after selecting density, this button, user can there's a new tab actually open on the right side part. Okay, so on the it's a temperature dependent density values are here. So user can provide the specific temperature and its density on this tab. Okay, and after selecting it, after providing the value, user also user can add the multiple points like this thing. I have selecting the add points. So that's how user can add the points. And by selecting the remove points, user can remove the points also. Okay. So user can provide the temperature value and its density value. And after providing the value, user have to select this return arrow. So its value actually updated in the software here. Okay. Now similarly for the density, specific heat and thermal conductivities, there is a temperature dependent properties are given. User can also provide its reference temperature dependent properties here. Now, next one is latent heat of fusion, which is a negative value user has to provide by the reference paper or experimental values. Absorption coefficient, emissivity, and there are solid to liquid leak constant, liquid to solid leak constants, and these are the some parameters user has to provide here. Okay, all of these parameters will be explained by our expert in the next lectures. Now, next, this one is only solid properties. Now let's move to the molten properties. After selecting the molten tab, again molten alloy properties will be open. Here we can see that there's a temperature dependent density, which is a melting temperature, which will be start after the melting temperature. So we can see that there's a density will be changing according to different temperatures. Now, similarly, specific heat, dynamic viscosity, thermal conductivity, and surface tension. These are the temperature dependent properties we are providing. Now, on the below side, there's solidus temperature, liquidus temperature, and absorption coefficient and emissivity. This value user has to provide in the PravaH software. Now, let's move forward to the vapor. Now, on the vapor side, we can see that these are the metal vapor properties, specific heat, dynamic viscosity, thermal conductivity. So these are the temperature dependent properties and its value user has to provide here. Now we consider that it's a heat of vaporization and vaporization temperature tabs it's given here. After providing the vapor value, let's move forward to the gas. So after in the gas tab, there is a shielding gas. This one is a shielding gas properties. So user has to provide the molecular weight, specific heat, dynamic viscosity, Prandtl number, and density. So user can also provide this gas property from this shielding gas. After like I am changing this shielding gas from argon to the nitrogen, we can say that its value actually changing. So also user can provide this value here, or it can provide its own custom value. To provide a custom value, user has to change the its custom value here, and he has to select the save alloy. After selecting the save alloy button, it's on my left side here. Save alloy. So user has to provide any custom name. After providing any custom name, user can save its okay. So its new save material actually saved, and we can see that on the left side alloy. On the alloy, we can see that there is a new material actually saved by changing its property. Now, similarly, user can save the shielding gas properties also. There is on left side button is here. Save shielding gas. Now let's move forward to our home menu again. So this one is a macro scale LPBF module. So on the macro scale LPBF module, on a home screen, there is a numerics and residual plot is there. So user can select the variable of the plot, and it can, when the simulation actually running, this plot actually changing during the simulation. So user can check its vapor fraction, inert gas residuals, current number, and the maximum temperature and different values. It can check. Now, next one is a process. In the settings, process are there. So after providing the material value, user has to select the process to uh, run the simulations. In process, we have to provide the scanning pattern. So upload the scanning pattern. It's CSV file of the how laser actually moving, where we have to provide the distance and the scan speed there. Upload powder size distribution, which is a .csv file also. After selecting it, we have to provide the powder size, diameter, and its percentage there. Okay. On the below part, there's a laser beam type. So we have provided some default some laser beam type like Gaussian. Some are uh, uniform laser, and different lasers are there. But we have new features where user can create its own custom shape laser beam profile like top hat, elliptical Gaussian, ring shape, and different laser profile it can create. Okay. which is the option is here, create custom laser. After selecting the create custom laser, there is a new tab actually open there. So in this tab, user can load the beam profile where he or she can create it there. Okay. Now after that, there is a add theta option is there. So previously I have done the one small webinar about the laser beam shaping. User can check about that, how to create a custom laser beam shapes. Now there is one option is there, after uploading the scan pattern, user can check is scan pattern is correct or not by clicking the check scan speed button. Also, after providing the number of layers, user has to update this thing, the number of scan layers here. Okay, and on the right side part, laser properties, user has to provide its laser beam component along the X, Y, or Z direction. So if the laser is on the Z, that negative Z direction, user has to provide the -1 here. And user has to provide the power, D for sigma, spot diameter, and Fresnel coefficient value of the solid to liquid, liquid to gas, liquid to vapor, and the solid to gas. Now let's move forward to powder bed preparation. User has to provide the powder bed by providing the load powder size, okay, on the by loading upload powder size distribution. User has to provide the average sphericity and standard deviation. So here is the powder properties user has to provide to how the powder bed actually sprayed. So after that, we can see that there's an option. For a third one is the initial chamber conditions. So how your chamber condition will be when the simulation will start. Preheat temperature user can provide, chamber pressure, shielding gas, gas flow at angle, initial substrate height, substrate clearance at boundary. So these properties parameters user has to provide to look, initial chamber conditions. Now after that, again we have to select the save button after providing all of this value. Then there's a reset button is there. So after selecting the reset button, all of the settings go back to the reset, and we have to select the back button to go back the home screen. Now I will show the third part is simulation. On the simulation, these are the some preference values and the periodization values we have to provide. On the preference part, user has to provide the accuracy, which will be starting from 10 to 100. So higher the accuracy, which will be higher the mesh size, max scorer number, performance, data sharing frequency, and this value user has to provide. And user can write the custom write intervals here. Okay, and on the periodizations, physical CPU processor cores user has to provide. Boundary condition, it can provide the thermal gradient at the substrate boundary. Okay, after providing this value, user has to save the button and go back to the home menu. Okay, now after providing all of this value, user can execution its project by providing the save all value. Right now I am not providing the project name, that's why it's showing the project location not set. Okay, after that user can run the solver by selecting the run solver, or it can stop the simulation. Some if he or she want to stop the simulation, uh, we have to select the save and terminate button. And if we have to resume, then we have to select the resume button here. If we want to see how much percentage of a simulation actually run or how much time will take, we have to select the launch console button here. So we can see that how much time will take to complete the simulation. Now after powder spreading, um, we can see that show powder spreading by selecting this button, and the show results too, we can visualize the results of the our process. Now let's move forward to the second model, macroscale WLM. Now it has the same simple GUI materials where all the properties are there, but there are some changing on the process parameters where we have to provide the wire parameters, where wire radius, wire clearance, inlet layer clearance, feed angle, feed rate, wire current. These are the value we have to provide. Also, other parameters are also the same, and we don't have to provide here the powder size here. We have to provide only upload scanning pattern. Now let's move to the third module, microstructure. By selecting it microstructure, we will move to the microstructure there. On the microstructure settings, in microstructure, after selecting microstructure, we have to select the settings. In the settings, we have to provide the simulation preference, number of spin states, and with adjustment parameters, depth adjustment parameters. Okay, and process parameters we have to provide, which are similar to the other simple GUI, and we have to provide the accuracy, performance, and a data saving frequency, and the number of the processors. On here, I see that max available processors are 12, so I can select the maximum 12, and minimum we can select according to our requirement. Alloy properties, we have to provide the solidus temperature, thermal diffusivity, thermal conductivity, and scan pattern we have to provide. Okay, now this one is the microstructure module. Let's move to the queue mode. If we have to run the multiple projects, more than one, then we can run from the queue mode here. So user can create the queue after selecting the create a queue, and it can run the LPBF as well as the microstructure. We can run the multiple simulation here when we are not actually here. So we can sometimes we have to check the simulation, and we have to see it's like how where its simulation actually going on. Okay, we can see the live process here, live status here, and we can edit the inputs, or also we can create the rules like multiple project we can create by providing the create rules here. Okay, so this queue mode and all of these uh, different modules will be like actually in detail explained by our next speakers. Okay, now fifth one is the AI module. So in the AI module, there is a train new AI model which is on the left side. User can create the train new AI model by providing the model complexity, model name, and their training data and the target training data. Providing all of this value, user can train the new AI model, and after providing this all of the data, we can train the new model. And using that trained model, we can uh, provide after training the after trained model, we can uh, generate the new data using that trained model, which is on the right side part. So after that trained model, we have to load the trained model here, and we have to provide the prediction, and we can predict the what the next outcome will be there. Okay, so these are the 5 modules which AM PravaH provide. Okay, so that's the simple user friendly GUI, and I think this is the GUI part, and thank you everyone for joining the live session here.